Hey y'all, in this video we're going to be going ahead and looking at another GRE question. So the GRE question, so this type of GRE question is different from the other videos I already have been posting. So this is the comparative one. So this is where we have to understand that this is an actual equation for us or an inequality. So the idea is that these statements are supposed to be compared to one another, and we're going to be describing who would be bigger, or could they be equal, or the information that they're providing is insufficient enough to give us a solution. So what we're going to go ahead and see is like what we can dissect from it and kind of understand about the problem. So the statement is telling us that if we add some random numbers, so if we just plug in random numbers for this that have to equal 21, then we can go ahead and say that those numbers, so we'll be looking at the back numbers. So the first statement tells us that if we add these two numbers and then divide it by 2, because it says take the average. So average is being divisible by how many numbers. So since it's telling us the average of those two, x and y, since there's 2, we go ahead and divide it by 2. If there was 4, we would divide it by, at that point, 4. So you just usually, when you're taking the averages, you add up all the sum of the numbers and divide it by how many there are. So in this case, since there's only 2, we have only divided by 2. So we're going to understand that that statement has to be x plus y divided by 2 has to be either less than 7, x plus y divided by 2 has to be greater than 7, or x plus y less than 2 has to be equal to 7. So what we can go ahead and do right now is kind of understand, like, okay, what am I going to be working with? What numbers can I use? We got to figure out actually what our numbers would look like. So when we look at our numbers, we're going to understand that. So what we're going to do is, okay, first say, okay, what numbers can give me 21? So right off the bat, the first one I can obviously think of is 7 plus 7 plus 7 is equal to 21, which is the same thing as saying 3 times 7. So then, okay, that's one case. So we have to think of, is there any more cases that could give us these representational numbers? You may have to struggle a bit and kind of work through some numbers, but what I would say is start off with numbers that you can think of, and just work through some cases and see what we can get. So first things first. So let's just try this. Let's just work with what we have right now, since we only know this. Okay. So the statement is that if I take the back 2, which is telling us this is w plus x plus y, supposed to be equal to 21. We take 7 plus 7 divided by 2, and then we say, okay, that's 7. Now in this case, 7 is equal to our comparative other 7. So we say, oh, okay, great, that one checks out so far. So then we may be leading towards that they're equal to another. But then, like I said before, we have to try various numbers. We can't just assume that the first case would work. So I would say try using single digit numbers, maybe trying to work your way up there. But the one that I found that worked would be 9 plus 6 plus 6. This would also give me 21. Now there may be more cases that you could use, but this is what you're kind of looking at here, that you want to prove, you want to see what the statement can do using alternative numbers. So what we'll say is we take the back 2. We got to look at the back 2 now. So what we're going to say is 6 plus 6, divide that by 2, which gives us 12 divided by 2, which is actually 6. And that's, if we, from that, we know that it can't equal 7, has to be less than. So if you get more cases that are showing you that it's not working, because we know that 7 is, we took the average of 7 and 7, which is 14. So this told us it was 14 over 2, and we noticed, okay, this would give us a 7, which would be equal to 7. So, but the reason is because we have various cases, and one case I just showed was 9 plus 6 plus 6. Since that one shows that the average isn't the same, we can automatically assume that the information is not very accurate. We couldn't actually dictate what would work. So, in this case, your answer would have to be D. You would have to select that the information is not, or like it's not, the relationship cannot be determined. So we can't determine it because we're getting too many random numbers. So what we'll go ahead and say is this one is not not good. So if you have any questions or comments on GRE questions, let me know. If you have any questions on GRE, let me know, and we can probably help you out here. Thanks a lot.